Hey, how's it going? Keith Morgan here for TechTyro.com, and today we're going to be taking a look at fluid simulations in Blender. So, if you haven't ever used Blender, I suggest you go and look at our intro tutorials. But if you're a seasoned professional or you just want to challenge yourself, let's get going on our fluid simulations. So, Blender has a built-in fluid sim, and it's very handy. It's very lightweight, and you can generally get some pretty impressive results even with lower resolution settings. Um, but if you don't know what a fluid sim is really made out of, let's just break it down for you via our fluid simulation main components. So, the most important part of your entire fluid sim is your domain cube. Now, your domain cube is a object, generally a cube or a rectangle, that contains the volume with which your simulation will be calculated within. If only space within that volume will be calculated in your simulation, otherwise it'll just be neglected and it won't make any difference. But your domain cube is also the object which becomes the fluid after you run the simulation. So as you'll see later, when we start with our cube, it disappears when the simulation starts, and if we highlight what will become our fluid, it is the same object as our domain cube was. Our other types of objects include inflow objects. These are geometry that spit fluid into the simulation, I suppose. And what really means by that is they create emission points for the domain cube to spring forth out of. And you can change the strength of the inflow, etc., etc. Now, outflow objects are a similar principle to inflow objects, except that instead of giving and creating geometry for the domain cube to exist in, if any part of geometry from the domain cube, once a fluid, reaches an outflow object, it'll be nullified and essentially be like going down the drain. You can also have fluid objects, which are fluids that become fluids themselves. So say you had a sphere and you made it a fluid object. When you started your fluid simulation, that object would just fall as a fluid. It would take the shape and then it would fall, or do whatever you have it doing in the scene. And lastly, we also have obstacles. These aren't the only types of fluid interactions you can have, but these are the ones we're going to be covering today. Now, what an obstacle is basically exactly what it says. It's an object that the fluid interacts with in such a way that it respects the volume and the geometry of that object as best as possible, and we'll go around it. After we set up our fluid simulation objects, we'll take a quick look at how to set up the physics for our fluid simulation, and likely we'll also cache our simulation via the baking process, and then we'll show you quick tips on how to play it back and render it. So, without further ado, let us get into Blender. So, we've opened up Blender here, and we'll see we have our default cube here, and what I like to do, especially with fluid simulations, is I like to move the cube up onto the ground plane. Now, because the cube starts as 2 Blender units by 2 Blender units by 2 Blender units, you can pretty much just move it up 1 Blender unit, and those are just these grid markers, and then it'll be resting flush with the floor. So you can hit G, Z, and 1, and that moves it up on the Z-axis by 1 Blender unit, landing it right on the floor. So, quite handy. This will be our domain cube, so let's just go and set up that right now. So if we go over here on our property panel, and with our cube selected, we go all the way over here to the physics panel. We will enable fluid, and we'll change its type to a domain object. Now, we'll just neglect all these features right now, because if we did anything right now, it wouldn't even do anything, because we don't have any other fluid objects for it to even know what the heck to do with. So we'll just hit Z to go into wireframe so we can see inside of our cube, and we'll hit Shift A, and we'll add a quick plane. And you can see it takes up the same spot as the cube, so we'll just hit S to scale it down, and then we'll hit G, and then Z, and we'll just move it up inside of the cube. And just so it doesn't get too hectic in there later, we're just going to scale it down a little bit more. Because an object that big, if you make it an inflow object, it'll just get bananas, and you will just fill this entire box with, like, in 20 frames probably. It's just a mess. So this will be our inflow object. So with it selected, we'll go to our fluid tab. And for fluid type, we will change it from none to inflow. And we will change its volume initialization from volume to shell. That's kind of important. It just creates a more accurate calculation for the fluid sim. And we will also change its inflow velocity on the Z to -2. We might have to tweak that later depending on which way it actually is oriented, but we'll get there when we get there. So we'll add a couple more objects. We'll hit Shift A, and we'll add a cube, and we'll leave it hanging out of the domain, but we'll just scale it in. So you get that. And this will be our obstacle. So with that selected, go to the physics panel, fluid, change its type to obstacle, and likewise we'll change its volume initialization to shell so that it only respects the outside faces. And generally you're fine with these other settings. And we'll add two UV spheres. We'll just make one. We'll make it really small. We'll say 10 segments by 5 rings, and we'll just scale it down. And we'll just hit 1 so I can see what we're doing. And we'll just move it over here. And we'll move it up. And we'll duplicate it with Shift D, move this other one down here. And these are going to be two different things. This one down here will be our outflow object, so any fluid that interacts with it will be nullified and deleted and essentially erased from the simulation. And this one will be our fluid object, so this one will actually become a fluid itself and add to what the inflow object is adding to the scene. So with this top one selected, we'll select fluid, change its type to fluid. And with this bottom one, we'll do the same, but we'll change it to an outflow. So we have most of our settings set up now. And so if we go and select our domain cube, just so you don't get any inaccurate viewings and you don't get frustrated, first thing we'll do is we'll change the viewport display from preview to final. So that just means what you see here is what you'll get rendered. Otherwise, it'll just be knocked down a bit and it might throw you off and you'll get inaccurate perception of what your fluid actually looks like. But we'll just leave it at the 65 resolution right now. And we'll just hit bake. And what bake does is it calculates the physics. And if we see up here, this little progress bar shows us how much of the simulation has been baked. Now I'm just going to escape to cancel it, because if we're doing it for the full 250 frames, it's going to take quite a while. So with our end frame value selected right here, let's just change it to 100. And that'll just automatically make our simulation only 100 frames long, as opposed to the full 250. So let's just hit bake again. And as it's baking, we can scrub through it and we can see what is happening. So you can see that the object itself doesn't become a fluid. The domain takes the shape of that shape, and then it becomes a fluid of that shape, and then it continues the simulation with that. You can see if just by hitting the arrow keys left and right, we can just scrub through the frames as they're simulated. And you'll see that as the fluid begins to build up, there'll be this ring of emptiness around the outflow object as it deletes the geometry. And actually, we can kind of see that right here. There's like a ring right below it where there's no fluid staying. But yeah, you'll see as more fluid enters the scene, there's just a dip there where it just doesn't exist. So that's part of the niceness of a outflow object. And you could have it just like a plane on the floor, and you could just have a hole on the floor for the fluid to go into and just have it erase there. You could even have that unseen, and if you want your fluid to disappear, you do it on off screen. And getting rid of the fluid will free up simulation time for other parts of the simulation, so that's always a handy procedure you could do there. So as you can see, our inflow object continues to pour liquid down, and it looks quite good. We have these facets, so with our domain object, as you can see right there, it's our cube. You can just go over here and turn on smooth shading, and it already looks more fluid-like. And just do this all day. But yeah. But as you see, I can just select our outflow object, and if I just hide it for a second, you see the dip where it exists, where it's been deleting fluid. And likewise, if we just hide our other cube in there, you can see the void it's left. And yeah, once you set up your fluid, it'll keep running with the same settings, same appearance. It'll never really change, unless you delete your cache. But you can set up some interesting things. So now that our fluid is finished baking, you can select it and you can change settings, but you'll have to rebake it to have them update. which is kind of a pain, but that's just how it works. You just got to rebake those physics. But, you can, if we just change this final resolution, it'll get higher resolution, and it'll look way more realistic. The smaller your faces are, i.e. the higher your resolution is, the more accurate the physics will be, the more accurate your fluid will behave with other objects, and just the better it'll look overall. But at a very high cost. It almost seems like you're baking a memory required. It almost goes up exponentially for each value you tick up your final resolution. So, be mindful of that. If we were gonna say jack this up to 200, and really you only want to do this for really like close projects or for final renders and stuff like that, you can notice that it just jumps up right up to 770 megabytes to cache that, and it's just a lot. So, work with as few subdivisions as possible in your fluid. Generally, I find 150 works for most things. 200 pushes it for a lot. You don't really need a lot of that. But there's some other physics settings you can change while you're doing that, and I'll just change this back down to 65 so we can rebake things if we need to. You can change the start and end time, and those are independent of the length of your composition in a way. They will update depending on the length of your file. So if you have, let's say we set this back up to 250, what this says is that at the start it'll be simulating it at 0 seconds, which is fine, that's what it should be doing. But at the end it will only have reached 4 seconds in time. So if you have your frame rate to match that, fine. But currently our project is set up at 24 frames per second, so at 240 frames, it's going at only 40% of the speed that it should be going. So, you can get some slow-mo effects, but if that's not what you want to jack that up to be the same number of seconds as that your project is in length. So let's say we can even do fast motion fluid. So if we drop our end back down to 100 seconds, or 100 frames rather, and we jack our end up to, let's say, 20, and we rebake it, you're essentially going almost 5 times faster than the composition is going to be played back in. So if you see on our first frame, we already have fluid touching the cube. I think on the last one, we didn't even have fluid touching the cube till almost frame 5. So, it just processes it a lot faster. So we'll just hit escape to cancel that baking process. And you have some other settings down here as well. You can change the fluid viscosity presets. If you really want to look into these, you can change them and make them custom to fit whatever fluid you're trying to simulate. But they do have some really nice presets. They have the honey, oil, and water. Honey obviously being way more viscous, and oil slipping, I suppose. And then you can also change the real world size. Now what that dictates is, if I go to frame 0, frame -1? No? Okay. Okay, that works too. If we go past where our fluid has been calculated, you'll see we have our cube again. And that's just because it hasn't had time for the geometry to be resorted out as a fluid. But this real world size dictates how big the scale of this cube is. So right now it's at 2.5 meters. If you wanted to simulate a much larger area, you could change it to like 10 meters. And you'll notice that your fluids behave much differently when they have to go 10 meters as opposed to 0.5 meters, really make it fit your scene. And then we have some other options down here as well, and these might be a little too advanced right now, but nonetheless, you can use smoothing on your fluid, and that'll give it a less jaggedy appearance. But you can also increase the subdivision, so it'll subdivide the mesh as it needs after simulating this first mesh. So if we were to rebake this, it'll look a lot smoother while still maintaining the cancel that, rebake. And likewise, setting those settings higher really makes the fluid simulation process take a lot longer to calculate. But you'll notice that this is way smoother to look at now that it's had some subdivisions applied to it, but at a cost of losing some of the major details and ripples. So it's a trade-off between jagged and detailed looks. So something else to think about. But if you're able to put your subdivisions up to 2, you can also activate particles. So it'll look like things are splashing off of your water. So I'll just choose some arbitrary values there, and we'll cancel our current fluid simulation, and we'll just rebake this. And you'll notice when we get to some of the splashes and stuff, you'll see a lot of particles just coming off of these. Yeah, if you get right in there. But likewise, you can only access those extra particle settings if you have at least 2 subdivisions on your fluid simulation. Don't know why they do that, but it's what's necessary, so that's just what happens. And you can see it gets pretty chaotic. You might not want it that much, but you know, it adds a lot of chaos and randomness, but you know, just depends on what effect you're going for. And yeah, so let's just quickly switch over to cycles, and I'll show you quickly how to make a really nice water texture. Well, rather, I guess I'll show you which settings make Blender give you a really nice water texture. It's very simple, like one step. So I'm just going to go ahead and delete our obstacle cube, our outflow sphere, not that it really did anything in this last one, and our fluid. So all that we have left is our domain cube. I suppose we also have our inflow plane, but we'll get rid of that as well. So we have this left, and it processed up to around there. So that's always good. And you know, you can pan around it. Looks pretty nice. Yes, so after we've switched over to cycles, we'll just go to the material tab, and we'll click use nodes. And for the surface type, we'll choose glass. And water has an IOR, index of refraction value, of about 1.33. And that'll just make the refraction seem a lot more accurate for water. If you were to give it a different value, it might look different, or might look odd. So if we just go over to rendered viewport, you know, we don't have any lights in our scenes, but you can really see just already how fluid and water-like that looks. So, you know, play around with it. Get familiar with fluid simulations, you know, try out different physics settings, and just see what works for you. So I hope that helped. This is Keith Morgan for TechTyro, signing off.